Hello students, good morning. Today in this video I am going to explain about Bohr's atomic model. This is one of the very important questions for your examination. So first of all, in this Bohr's atomic model we have to study about the postulates of Bohr's atomic model. On the basis of postulates of Bohr's atomic model, I am going to derive two equations. One is an equation for velocity, another one is an equation for the radius of the Bohr's atomic model, isn't it? So let us start about the postulates of Bohr's atomic model. Bohr's atomic model. So Bohr has assumed the quantum nature of the atom. He has considered the quantum theory to explain the structure of atom. So according to quantum theory, energy is not continuous, it is a discrete packet. On the basis of that, he has assumed that so atom consists of centralized mass of the atom where the whole positive charge is concentrated. The whole positive charge is concentrated, and this positive charge is exactly located in the center of the atom with very small space of the order of 10 to the power of minus 15 meters. So this is what the order. So within that small space, the whole mass of the atom is concentrated, and the electrons are revolving around the nucleus in an exactly circular path. So this is the path occupied by the electron. If it is only one electron, only one path. If number of electrons increases, the path numbers is also increases. So this is the charge of the nucleus plus Ze, and the electron is revolving in an exact circular path. So he has made three assumptions to say about the structure of atom. So in the first assumption, so that assumptions are very important for the examination. For 3 marks, this is one of the important questions. So in the examination, they will ask, write Bohr's postulates. Direct question. So you have to write 3 postulates here. The first postulate says about the structure of atom. It says about the stationary orbit. So very simple. Bohr's first postulate states that the electrons revolving in a stationary orbit around the nucleus in a circular path. So this stationary orbit is fixed for a fixed electron. If number of electrons increases, the number of stationary orbits can also increases. If this is the stationary path, if the electron is revolving in its stationary orbit, there that electron do not radiate any energy. If the electron is revolving in its own orbit, then in that orbit electrons do not radiate any energy. So it says about stationary orbit. So Bohr's first postulate is in an atom, the electrons are revolving in a stationary orbit around the nucleus in a circular path. This is the first postulate made by Bohr. Second postulate, he says about the stability or quantization of this stationary orbit. About this stationary orbit, it can say about quantization concept. It means they have used quantum theory there. So Bohr's second postulate says that whatever the electron revolving in its own orbit should have their angular momentum. Here he confirms that the angular momentum of the revolving electron in its own orbit is quantized. Angular momentum is quantized. So the quantized value is given in the second statement. So in the second statement he has given the quantized value. The angular momentum of the orbital electron, angular momentum is represented by L, is equal to integral multiple of h divided by 2 pi, where h is called Planck's constant. He has used the knowledge of quantum theory. So in the second postulate, he says that the angular momentum is quantized, whose value is exactly equal to integral multiple of h divided by 2 pi. So hence, according to Bohr's second postulate, the angular momentum of the orbital electron is equal to integral multiple of h divided by 2 pi, where n is an integer 1, 2, 3, 4, etc. So this n is also called as principal quantum number. Principal quantum number. So n is the representation of principal quantum number. Okay. So now let us move on to the next postulates, that is Bohr's third postulates. So according to the Bohr's third postulates, so this third postulate says about the energy radiation by the atom. So according to Bohr's third postulates, suppose say it is the nucleus, the whole mass of the nucleus is concentrated. I mean the whole mass of the atom is concentrated in the nucleus, and the electron is revolving in its own orbit called stationary orbit. This orbit having angular momentum is quantized, that is from second postulates. So the quantized value is h divided by 2 pi, where n is called principal quantum number. N starts from 1, 2, 3, 4 up to etc. Here, in the third postulate, it says about the energy radiation. This is one orbit, this is another orbit. Like that, different electrons is having a different path. So these paths are called stationary path. If this electron jumps from one orbit to another orbit, whether it may be towards the higher energy or towards the lower energy. So if it is, jumps from higher energy level to lower energy level, it can emit radiation. If it is jumps from lower energy to higher energy level, it absorbs radiation, because there are two types of radiation. One is absorption spectra, another one is emission spectra. So depending upon the energy level, if the electron jumps from one state to another state, let us consider E1 is higher energy level and E2 is lower energy level. E1 minus E2 is equal to h nu. Again we use the quantum nature, quantum theory, I use energy whose depends on, the energy depends on frequency has taken. He has taken complete 100% quantum theory to explain the Bohr, structure of atom. Clear? So I want to repeat the three postulates once again. So these three postulates are very important for the examination. So the first postulate says about the stationary orbit. Second postulate says about the quantum, angular momentum is quantized. Third postulate says about the radiation of energy, whether the energy is absorbed by the atom or the energy is emitted by the atom. That depends on the electron jumps from higher energy to lower or lower energy to higher. If it is jumps from higher energy to lower energy level, it can emit radiation. If it jumps from lower energy to higher energy, there the electron can absorb radiation. So on the basis of this quantum nature, he has successfully framed three assumptions or postulates. So the first postulate is the electrons revolving around the nucleus in a stationary orbit. In the stationary orbit, they do not radiate in energy. Second postulate, the angular momentum of the electron revolving in a stationary orbit is equal to integral multiple of h divided by 2 pi, where n is a quantum number, that is principal quantum number, h is Planck's constant, h is Planck's constant, Planck's constant. Clear? And the last assumption is the energy radiate when it jumps from higher energy level to lower, or lower energy level to higher energy level. So if the electron jumps from one energy level to another energy level, so it can absorb or emit this much of energy, where h is Planck's constant and nu is frequency of emitted radiation. So clear now? So with the help of these three postulates, Bohr has derived an expression for, first I am going to explain about the expression for radius of the orbital electron, and after that I am going to derive an expression for the speed of orbital electron. So in this video I am going to derive these two derivations. So first of all I will consider the first derivation like this. The first derivation, first one. So on the basis of Bohr's postulates, I am going to derive the expression for orbital radius. So first I am going to derive the expression for orbital radius. Okay, so here to derive the expression for orbital radius, so this is what the structure of atom on the basis of three postulates. This is what the orbital radius. First of all, I am going to derive the expression for orbital radius. To derive the expression for orbital radius, first let us consider the second postulates of Bohr's atomic model. So what is the second postulates of Bohr's atomic model? So it says that the angular momentum is quantized. So what is the formula for angular momentum from Bohr's second postulates? So what is Bohr's second postulates? Angular momentum is mv. mv is mass into velocity, is linear momentum. If you multiply linear momentum with the mv r radius, then it will convert into angular momentum. So these things you already studied in first PUC itself while studying angular momentum, which is equal to, instead of L, I was taken mvr. So according to second postulates, it is integral multiple of h divided by 2 pi, where n is called principal quantum number, h is Planck's constant, m we know that mass of the electron, where m is the mass of the electron, m equals mass of electron, v is speed of electron, and r is orbital radius. So this is what orbital radius. Now let us move on to the next step. I want to simplify this equation for the velocity. So if I simplify this equation for velocity, v is equal to nh divided by 2 pi m into r. Clear now? So let us consider this equation number 1. This is according to Bohr's second postulates. There we have taken the angular momentum is quantized. Now let us move on to the first postulates. So first postulate says about the stationary orbit. If the electron wants to revolve in this specified orbit where they do not radiate any energy, in that particular path, this electron is negatively charged and it is revolving around the nucleus, which is completely positive charge. The charge of the nucleus is plus Ze and the charge of the electron is minus E. So these two will, unlike charges, unlike charges can experience electrostatic attractive force. So if they have only attractive force, they do not radiate or they do not revolve exactly in a circular path. There must be another force which is exactly equal and opposite to the electrostatic attractive force. That is what we call them as centrifugal force. So to get the stationary orbit, we need to consider two forces. One is centripetal force, another one is centrifugal force. Centripetal force. So from first postulates. So from Bohr's first postulates, the electrostatic force is exactly equal to centripetal force. So what is centripetal force? mv square divided by r. M is mass of this electron which is revolving in exact circular path of radius r, moving with the speed v. So where v is the velocity of the orbital electron. Where v is the velocity of the orbital electron. So which is exactly equal to electrostatic attractive force. So why it is electrostatic attractive force? Nucleus is positive charge, electron is negative charge. We need to consider Coulomb's inverse square law. 1 divided by 4 pi epsilon naught. It is Coulomb's constant. Epsilon naught is called permeability or permittivity. It is permittivity of free space into charge plus Ze. Another charge is E into E square divided by distance square. Clear now? Now one R get cancels. In the next step, what I am going to do? Just I am going to substitute this to here. Clear now? So I will call this is equation number 2. Substituting equation number 2. 1 in equation number 2. We'll get the m, right, as it is v square. V square is square of this term. N square h square divided by 4 pi square. 2 square is 4. That's why I have taken 4 here. Pi square m square r square. Pi square m square r square. Clear now? So here one r is there, that is get cancels with this right hand side. So this m can also cancels one time. So which is equal to, right, as it is 1 divided by 4 pi epsilon naught into z e square divided by r square. One time r get cancels. I used to write only r. Now I want an expression for orbital radius, means you can simplify this for r. So r is equal to, see, transfer r here. So these terms will go to here. 4 get cancels. Pi one time get cancels. So write the remaining terms, you get the expression for orbital radius. So r is equal to, transfer here, and these terms will come to denominator and these terms will go to numerator. So pi m z e square is there. R one time get cancelled. R square is here. R one time get cancels. So I want to write this R here. So this it comes here. So to avoid confusion, I want to write one more step here. So write as it is remaining terms n square h square divided by 4 get cancels pi m one time r one time, which is equal to z e square divided by pi cancel, 4 cancels, epsilon is the only term, epsilon. So from this we can get r is equal to orbital radius r is equal to, if r comes here now, epsilon naught n square h square, epsilon naught n square h square whole divided by, if r comes here, the remaining term is pi m z e square, pi m z e square. So this is for nth radius. If it is n is equal to 1, here 1. If n is 2, 2 here. N is 3, 3. Clear now? Where r is the radius, Rn is the radius for nth orbit, where n is the principal quantum number. If the atom having only one electron, n is equal to 1. If it is having 2 electrons, n is equal to 1 and n is equal to 2 for second orbit. Isn't it? So this is the expression for orbital radius. If the z is 1 for hydrogen atom, if I consider for hydrogen atom, the value of z is 1. Then the expression for radius of an hydrogen atom becomes Rm is equal to epsilon naught n square h square divided by pi m e square, because z is 1. So for hydrogen atom, if I want to write the expression for hydrogen atom. So what is the formula for orbital radius? Rm is equal to epsilon naught n square h square divided by pi m, z is 1 e square. Clear now? This is for hydrogen atom. So this implies that radius is directly proportional to n square. Radius is directly proportional to n square. Why it is directly proportional to n square? Epsilon naught is a constant value. Permittivity 8.854 into 10 to the power of minus 12. H is constant 6.63 into 10 to the power of minus 34 joules second. Pi, you know that 3.14 or 22 by 7. M, mass of electron, is also constant 9.1 into 10 to the power of minus 31 kg. And charge of electron is also constant 1.6 into 10 to the power of minus 19 coulomb. So with that, we can clearly say that the radius of the orbital electron increases if the principal quantum number increases. So on the basis of this formula, Bohr has successfully derived that the radius is directly proportional to square of the principal quantum number. Directly proportional to square of the principal quantum number. So now let us move on to the second expression. So we already derived the expression for orbital radius. So similarly, I am going to derive the expression for orbital velocity. I will take orbital velocity. So to derive the expression for orbital velocity, let us start. Let us directly take. We know that orbital radius. So what is the formula for orbital radius? Rn is equal to epsilon naught n square h square divided by pi m z e square. So you call this is equation number 1. So in the next step, you can take Bohr's second postulates again. So from Bohr's second postulates, so what is Bohr's second postulates? Angular momentum of the orbital electron is equal to integral multiple of h divided by 2 pi. So Bohr's second postulate is m v r is equal to n h divided by 2 pi. So use this formula for velocity. So if I use this formula for velocity means orbital velocity v is equal to n h divided by 2 pi m into r. You call this is equation number 2. Now you replace r here, equation 1 to equation number 2. It means substitute equation 1 in equation number 2. If you substitute equation 1, substituting equation number 1 in equation number 2, we get orbital velocity n h divided by 2 pi m into r. So if I substitute r here, so here it will become reciprocal of that, because r is in the denominator. If I substitute the whole term here, so denominator will goes to numerator and numerator will goes to denominator. So that is pi mz is square, mz is square whole divided by epsilon naught n square h square. So you strike out the terms which is get cancels, n1 get cancels, h 2 times is there, 1 time get cancels, pi get cancels, m get cancels, epsilon naught h z. Okay, you write the remaining terms. V is equal to n z square divided by 2 is that 2 epsilon naught n h h. Clear now? So n already 1 get cancels, n no need to write. Z is square 2 epsilon naught n h. So this is the orbital velocity for nth element. It means nth orbital velocity. Clear now? Z is square divided by 2 epsilon naught n h. 2 epsilon naught n h. So if I substitute the values, all constant values for hydrogen atom, Z is 1. So for hydrogen atom, V n is equal to E square divided by 2 epsilon naught n h. So this clearly says that E is constant, charge of electron is a constant value. So you know the value of charge of electron. 2 is a number, epsilon naught is again constant, h is also constant. It means only the principal quantum number is the variable. So this equation clearly says that the orbital velocity is inversely proportional to principal quantum number. If the principal quantum number goes on increases, the orbital radius goes on decreases. If the principal quantum number goes on increases, orbital radius increases square times. Clear? See here, if this is the first orbit having certain velocity, if this is the second orbit, orbital radius increases, speed decreases. Third orbit, orbital radius increases, again speed decreases. It means if n increases, orbital radius increases, the speed of the electron goes on decreases. This is what the thing Bohr wants to explain, and for that one he has used these two equations. So one is for orbital velocity, another one is for orbital radius. So these two derivations are very important for the examination. So I kindly request from all my students, please watch this video carefully and practice by writing these two derivations. Right? So if we have any doubts related to these two derivations, you can directly ask me a question for that. Okay, thank you for watching this video.